As the final step in our proteomics experiment, we have made, a publication quality graph. It, looks really good. We could definitely submit it to a journal article, but we probably want to share our results with other coworkers who may or may not use R or Galaxy. So the best way to do that is often in Excel. And what we're doing in this assignment is creating a single spreadsheet that has two tabs, one for proteins that are upregulated in the metastatic samples, and the other that are upregulated in the RDEB samples. This is very similar to what you did in the tutorial on Galaxy. So you have this step of filtering the MS stats results. We're going to use column 3 is the log2 fold change column. If it's a positive value, a high positive value, here the value is 0.58, we're going to use a cutoff of 2. We'll put it into the metastatic folder or metastatic data frame. And then if it's a large negative value, so on the Galaxy filter, you set the significant log2 fold change to be 0.58, we're going to do -2. Then you were going to put it into the RDEB data frame. Once you have those two data frames, your job is to write it to a new Excel sheet where each sheet is named the condition, and you name your file last name.sigprot. So that's going to show you, this video is going to show you how to do that. So let's go to Posit Cloud. I have already uploaded, the significant proteins. I've already completed assignments 3.17 and 3.18 to create the volcano plot. So now I just need to put the data from that list into an Excel sheet. I'm going to open a new tool to do this. So the package is called Open Excel SX. This is available from CRAN, so you can get it just by doing packages, install packages. Run the library command to make sure that I have that tool available. And I don't want to use MySig3 because this is going to have the data that I most want, the information about the individual protein identifiers. It won't export to Excel because just like we've been doing all semester, when we export to Excel, we turn row names off. So I need to get this back into a data frame, and I can do that pretty simply with row names. So I make a new data frame called MySig4, and I bind together protein, a new column that's equal to the row names of MySig3 and the rest of the MySig3 data frame. Once I've run that, you see that now that data got copied over into a new column called protein. You can double check that all the row names and the information in the row match. So now I have that data for writing it to Excel. Then I'm going to filter my list. So I am looking for this condition. I want to only keep the rows where the value is very positive, greater than +2, or where the value is very negative, less than -2. Once I've created those filters, you can see them up in the environment. So there's 6 proteins for meta and 3 proteins for RDEB. And then I can write the data to a file. The list that I make has 2 items for every sheet that's going to go into the file. So the first is what's the sheet tab, what's the tab going to be called in Excel. So metastatic is going to store the data frame my data, and the RDEB sheet is going to store the data my RDEB. Now I write that to a file, and we can open it up and see what it looks like. And you see that it automatically created these tabs. In Excel, it's relatively easy for me to expand the column, see what the full identifier is, and then copy and paste any of these identifiers into UniProt and look up what the protein's function is. Having this skill is something that I think is really valuable in bioinformatics. It's a very simple thing to do at the end of your workflow. You've gone through much more complicated things than writing a nicely formatted spreadsheet for someone, but it's a powerful way to share the material with other people on the team. And this is something that almost everyone can open this on their computer and feel good about the data and add their own columns, add their own information about why these proteins might be biologically relevant. So I think part of being a good team member on a bioinformatics project is this ability, being able to share the data after you're done with the analysis.